The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, the group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong here with Mr. Dane DuPont of Hawaii Tracker, and we're bringing you guys another Hawaiian Volcano Tracker update. We're going to cover Kilauea and Mauna Loa as usual today. There's not been a whole lot of change in the volcanoes, but we'll go through the paces as usual. So all is still well, no increased hazard. We'll go through all the monitoring signals, give you guys a summary of what's happened this past week. We'll talk about the fire at Mauna Loa signals, go through some research roundup later on, volcano watch, all the usual stuff. So we did go, just kind of round up a little bit, we were out in the community this past week, activate Puna, revitalize Puna. Any feedback, Dane, from this past week?
It's good to, see the county and everybody coming out and giving those kind of updates, quarterly updates, something along those lines. Keep the community informed on what's going on, even if what's going on is us waiting for environmental assessments and environmental impact statements.
Right. Yep. So yeah, good to hear all that. We will share the County of Hawaii video when it is out. There's a recording of that available that we were involved in. And otherwise, we'll get into it. Dane will be taking questions and leading a discussion on the chat and inserting some here into our discussion as we go. So let him know if you have any questions or issues with our audio or video. Apologies for our late start today. We did have some issues that we wanted to take care of before we even went live. So here we are, finally. And without further ado, let me transition to Kilauea. And we're starting off with this picture of the rainbow from the V1 vent, V1 camera here that Dane pulled for us. A nice little interesting shot, just captured with a rainbow and a lava lake in the background. I didn't really see it glowing in daytime, but pretty cool. So today we're going to start with monitoring data, do it a little bit different. I'm going to start off by showing you guys this most recent eruption map that came out a couple of days ago from the summit. July 12th, our newest statistics are 95 million cubic meters of magma that has come out. 94.8 actually, or 25.0 billion gallons. That's our most recent tally here. So that's, if I zoom it in, let me see. Reload it. Zoom it in right there, all right. So 25 billion gallons. 25 billion gallons, 94.8 billion cubic meters. And it's come up 427 feet or 130 meters since the end of September. And that's added to what was there already, right? So we're still well over 1,100 feet in total from post 2018. So interesting how that is rendering weirdly on my screen at the moment. But in any case, our footprint of the active lava crust hasn't changed a whole lot. Active lava area within it and a couple of islands in here as well. But really it's those numbers that are most interesting to me. So it's coming up still steady despite all the changes, despite all the deflation cycles we've had. And here is our most recent plot with that 95 value here at the right end. So you can see that maybe a slight, if I zoom it in, maybe a slight decrease in that accumulation rate, but it's still climbing up steadily, as it appears here. And of course, this is the red line we're looking at, is this current eruption of 2021-22. The blue line is that 2020-21 eruption, which we're way past now and is just here for comparison. So that's the actual total volume accumulated. And if we look at the actual rate that is between these different maps, we are currently now at this value of 3.6. Right? So let me zoom it in here to this right end. You can see that we have had spikes up to 5.9 was a few months ago, and then it came back down into the 3s. It seemed like it was climbing. We hit a 4.2 about a month ago, and now we're back down in the 3s. So natural variations are normal. Of course, we're averaging, from, in this case, like this averages from here to here to get that 4.2, that averages from here to here to get that 3.6. So these are all averages, but it helps us keep track of what's going on. And so a little bit lower, maybe 10%-ish lower than it was about a month ago. And if we look at the actual GPS data, you can see that there's still extension occurring north to south across Kilauea caldera. There's still contraction, albeit slower recently across Pu'u'u's rift zone, north to south, still decreasing, although a little more shallowly, a slower slope than before, right up here. And we'll see if that pattern continues to change, or if it's just a temporary slowdown like we've seen here, areas like this in the past as well. In any case, nothing alarming there. The summary of lava depth from end of September until now is coming up Saw this period of fluctuation when lava was pointing to lava surface, just like we're seeing around now. Now you might notice that if I zoom it in here, the last week of lava depth with a laser rangefinder from the USGS HPL, that about a week ago we were coming up and we actually had a little peak over the weekend, Friday, Saturday, Sunday, and then after that, for most of the week, it's been coming down in lava depth. And that's following a pattern of our summit tilt, ground tilt, which is our proxy for pressure in a volcano. A couple of little fluctuations here over the weekend, but at a higher level, and then a drop down and a long, almost 5 days now of deflation, which is the same as the previous 2 deflations. So the lava depth has been, over the last month, has been fluctuating accordingly. Here's the last month. On top is the lava depth by our laser rangefinder, and below is the summit tilt. You can see, looking at the tilt first, a month ago we were having deflation-inflation events, but we had they were smaller in amplitude and shorter in duration, both, right? This one as well. And really the 3 we've had since then, this current one we have going on now, that one, and the one before that, and the one before that, were all bigger as far as the depth and the duration as well, right? So in total for this graph, if you look at it, there's 5 days here, there's 5 days here, there's 5 days here, there's 2 days and 2 days. 19 days-ish out of our last 30 days have been in this deflationary kind of phase. So lava levels have been a little lower on average, but still present within the active lava lake. And less ooze-up flows around the perimeter, although you are getting them during these in-between pulses that are not lasting as long as they were before. So that's the corresponding lava depth, pretty much mirroring the summit tilt we're seeing here over the last month. And likewise, so is the gas. Here's our summit SO2 scale on there, yeah. So here's the last month on the bottom, and then this is 3,500 tons per day and 500 here at the bottom. So the last 3 data points have been between 1,000 and 1,500 tons per day. You can see that that corresponds to this low part of the deflation-inflation cycle up here. During the high part, we get that high value that's between 2,500 and 3,000 tons per day, and then back to the low value right over here. So last week we talked about how there was probably a data point missing right in here that would belong somewhere up in here, and this week we actually have it to show the pattern there. So current values are actually low, but just like that, they're all just like the lava level and the ooze-up flows, they are spiking once in a while during these inflationary phases. So that is our monitoring data today. So we're going to switch to looking at some of our time lapses, and that will be how we summarize here what's been going on for the past week. So let's turn here to our KW camera. So the KW camera is up on the west rim of Kilauea caldera. And here's that last 24 hours view from the USGS. The main active lava lake right here in the center, all the gas and fume. See some clouds, a whole bunch of rain, a rainbow comes across. It's been pretty rainy the last day. Yesterday was really raining on a volcano. And it will be again this weekend as we have the remains of a hurricane passing nearby. So some unstable weather recently, and that's led to some of these views you're seeing here in the last 24 hours. Here. Okay. Here's the last week of the KW camera. And you can see mostly this persistent lava lake in the middle, but then there is an ooze-up phase that occurs here in that second and third day. It dies off pretty quickly, and then we're back to maybe just some low-level oozing up on the northern edge here, and persistent lake being the most active area as usual. And despite all this deflationary time, you can see the active lava lake has remained circulating at the surface, just at a lower level below that wall of the pit that it's in, right in there. So I can zoom in a little more, perhaps. You can see that during that inflationary pulse that comes, I think, right in here, get an ooze-up flow over here on the eastern edge, and something happening over here in the south as well. But let's move cameras so we can get a better view. Here's our F1 camera for the last week as well. See the lava lake. You see actually ooze-up flow coming in on the southeast, and then followed by the one in the northeast. Camera gets over saturated there, so we could lose the color, but then it comes back here. We're looping it back around. So I'm going to zoom it in here. and let it go all the way around past the flickery black and white and back to the beginning, because the lava level is actually deep within this pit, and you can actually see at the beginning of the cycle that it splashes up on the edge right there. Right there. It's that little edge of pink that comes around. A slight little overflow, very brief during that surge that occurred last weekend. So I zoom it back out again so we can see that surge and then the timing, how it goes, and then this goes, and then this goes. 1, 2, 3. There's a sequence of it. It's interesting to think about how that tube system beneath the crust might be transferring lava. Obviously, it comes from this west vent complex over here, probably in this way first, and then it finds some path. It'll overflow right over there. Find some path to over here, and to over there. Perhaps not in that area. It could be going branches and just getting there at different times, right? But that's more or less the order that we're seeing today. Pretty cool to see that little sequence, but otherwise it's been pretty quiet on top of the volcano. The current view of the F1 camera is this. If I zoom it in, you can see it's a little blurry. Probably it's a steam obscuring and losing the focus here. But you see there's a little bit of a gap between the top of this dark purple and the orange, this more pinkish color. That's showing the wall of the crater that the lava is circulating within here, wall of this pit. So that's right now, and we'll keep moving on. This is the V1 camera for the past week. And you can see that lava's coming in from this side. It's really sped up, so you really don't see the motion as it moves continuously. It's looking kind of jerky here, but it actually is flowing in that direction. It's submerging into the pit over here. It's moving into the southeast pit over here, and it's going under this northeast pit over. So that's most of what you see. We zoom it in. Let's look at the southeast pit here first that we like to look. We see a little bit of that overflow covering this septum between them, but really the lava level doesn't drop enough for us to see any opening or anything like that. So it seems like this little isthmus is actually, oh, they're poked open actually a little bit at the very end there. You can see through that opening, but it seems thicker than it was before, right? We're seeing those more delicate arches and having collapse. Right now, this seems to be a thicker slab that's been overflowed. So if lava level drops enough, maybe we'll see it reopen, or maybe we won't. It'd be interesting to keep track of here, see if that closes off or what happens. And we know it actually, the lava coming across here must sink down in here somewhere and recirculate under the crust towards those ooze-up. So over here on this eastern sink, we'll call it, right? Where the lava is sinking back down, and the gas bubbles in the lava don't like that, so they bubble back up, and it causes a spattering zone right over here. When the lava level was high, it was forming this almost like a spatter rampart, right? This big spatter cone that's hanging over the edge of the crater. And I know it's jerking around quite a bit, but if you focus on the area right in here, you see that these bits of spatter are forming right in here, forming and falling off, and forming and falling off. It's pretty cool to see how that dynamic contact zone there is evolving. You don't see a whole lot on this northeast pit. If I zoom it out a little bit, maybe you get the hint of this cone growing over here. Early in the sequence, but it's right on the screen here. Early in the week, it's a little flatter. And then later, you see this cone coming up right in here. Minor changes around the margin of the lake. Cool stuff to look at if you're visiting a park. See the spattering zones. You can see sometimes the west vent has been spattering and shooting some bursts of lava into the air as well. But that's what you can expect to see at the park. Most recent view is up here, showing that looks like a pretty big cliff now on this south side here compared to the lava level, since the lava level is currently still dropping with our deflation-inflation event. That is our current view. A couple more cameras to get through for a summary. This is a B1 view, so we're looking from the west, or from the east back towards the west. Our active lake is at the far end, and we're going to look at the ooze-up flows that come up. Like when a surge comes through, we see there's a little ooze-up flow over here, then there's one over here, and then the big one is going to occur right underneath. So that's the highlight of the camera. And then the rest of the week, it's going to be looking at the glow across the crater and looking at the glow within these little tornadoes, right? You guys saw this flow come in here at the bottom. And that is our B1 camera. down drop block area. Currently, the B1 camera looks like this. See, looking at the texture, since we just saw that flow over the last week, you can see how it's actually quite a bit buckled today. Right, there's still inflation of the crater floor. The crater floor is still rising as lava comes underneath it. Seems to be buckling around here, and you can see areas where, as the lava is traveling underneath this crust, and the gas is escaping from that lava, it's coming up and causing these mineral precipitations or alterations of the crust. So interesting stuff. One last camera to mention is our S1 camera. The S1 camera did come back online and went back offline again on the 11th. So once again, we don't have a whole lot to show you guys for this past week of the S1 camera. But thankfully, the SGS maintains many others. I'm sure they are working on it. So there's one last camera view to share with you guys, and that's actually the V1 camera asterisk, because they moved it for a few hours, as Dane got it here and captured. So we're looking at this west vent complex down here in the bottom left, and it appears that this is imaging mostly this gas cloud that's flying out of the vent here, this vent complex, right? So remember, our Volcano Watch last week was discussing imaging SO2 emissions with the UV cameras, and I have to just wonder, right? It's just a speculation, but seeing this visual video of the gas plume reminds me of that Volcano Watch last week, when very similar views. And perhaps they're pointing their UV camera at this area and using this camera for some kind of check. In any case, the gas is the focus of this video, as you can see here. So we'll use that to transition to our hazard talk and talk about really the only major hazard for this eruption is volcanic gas. And here is the most recent VOG model. It's not really that bad because the actual emission rates are pretty low still. Also, the weather has been really clearing out the VOG as far as wind, rain, and all of that. So it's not really been as bad, generally speaking. But what happens with a strong wind is that the plume, rather than being dissipated and going all over the place, ends up being more intense in a smaller area. So there are times where it does hit certain places, and you do see it actually affect the sensors there. So here is our most recent purple air. This is a community citizen science initiative. People can buy these purple air monitors and put them at their house and join a network, and then everyone can get access to the data. So we're looking at Pahala, for example, here. It's in a green at 0 right now. But you can see by clicking in it, you get a history chart, and it has gotten yellow a couple times in the past week over here, over at Wood Valley. Come down. Let's try South Kona, where we're at 28 ppm, and you can see that that station actually jumped in to the through the yellow, through the orange, and to this red a couple times here, and almost to the purple this week. So definitely is still a thing, and it can be more intense in those areas when that is happening. So the national park follows that same pattern. You can see most of the viewpoints in the national park are in the green. They're all upwind of the emission source, blowing to the southwest. But looking in at this little inset map, these Kahuku facilities down in the south part of Mauna Loa can get directly impacted by that dense plume coming across. So while it's green for most of the park, and see green on an advisory history here, if we go by site, then you can see that the Kahuku facility is the only one showing anything besides green, and it's in a yellow a little bit right over here. Early this morning. So looking pretty good in the park actually as well. Okay, so we are going to switch here to showing you guys a park map and talking about lava viewing briefly. We don't have any new footage once again this week, but we're going to spend extra time on research from 2018, so it's just as well. But the viewing areas are still from Uekahuna, Kilauea Overlook over here, where you might have only seen that one ooze-up flow over the past weekend, and otherwise not a lot to see there, besides these big hornitos and the steaming crater floor, especially with all the rain. When you get a lot of rain, you see lots of the steam coming up. See what areas are hot, and that's pretty cool. So that's Uekahuna. No direct view of the active lake, but you can see it from Kupinaipali, aka Waldron's Ledge over here area, and along that crater rim trail, almost to Kilauea Iki, and also from the south from Kanakakoi. It's getting crowded. I went to Kanakakoi several nights ago. Might have been early in the week, and yeah, it gets pretty packed in there in the evening still. So plan accordingly. Parking lots closed and all of that. Right. So let's just make sure to mention you should check the national park website. Right. They have all their alerts. Closures, for example, Mauna Loa Road is currently closed due to wildfire. Overlooks closed for repair, accessibility improvements, those kind of things. Also, any information on COVID would be on there. And you can see here eruption viewing with current conditions at Kilauea Summit, linking to that USGS webcam right there. Right, viewing locations, all that is all shown right here. Right, so following that USGS webcam is the same V1 camera we've been looking at. And there it is, and showing that level last 24 hours. Lava Lake still active for viewing up there. So that is the viewing report this week. We will switch to looking at the media released by the USGS this week, starting with that set from July 11th. So July 6th, monitoring station maintenance. On July 6th, HVO technicians conducted maintenance on volcanic gas monitoring station in Kilauea Summit region. Photo by M. Kapos. On July 8th here, continuation of the summit. Having a missing picture, but the lava level has been shown to drop by several meters or yards. Looking closely at this, this is that northeast pit that we saw. I pointed out that we couldn't quite see that cone growing on the edge of the F1 camera there, but here's a zoomed in view showing a little bit of that cone growing right in there. Perhaps I can blow it up even more if I open it separately and click through to the original. A little longer. More. There it is. Now I can zoom it in and get a little bit better view of that spatter cone here, where that lava is moving in and sinking down and creating that extra little ledge shooting up over the edge. Right? Go. Nope, it's back in. There, got it. So next photograph, this is the actual west vent complex, and you can see maybe little bits of lava. I can see shooting up above the vent here in this particular photo. Easier to see, of course, when you're there in person, and you can see the motion. And if it's nighttime, you can see the glow shoot in the air, and it's all visible from the overlooks. So the low-level spattering was intermittent and reached heights of no more than 10 meters or 33 feet above the vent. Photo by M. Lowen in the USGS there. And here we have a view of that eastern section. There is that series of cracks that has a discoloration of gas on it there. And the recent ooze-up flow area was right in there. I zoom it in. Anymore here because it's not working too well, but if I zoom it in, you can see where these steaming hornitos actually are. And I do see a question here from Richard asking if he thinks the biggest hornito looks like it's getting bigger. What have you got, Dane?
I sent you a photo of a side-by-side comparison. It's versus today of that hornito. So you got the side-by-side available.
Let me get it up here. So go Richard. Dane composed the answer for you. June 1st there on the left. And July 14th here. Looks roughly the same size to me. Roughly the same shape. I think this one on the back looks a little bit bigger right here. Slightly taller. compared to here. But otherwise looking pretty similar there. So it looks like they haven't grown terribly, but they are occasionally spattering as well. Really, the more they spatter, the more they can grow and collapse and all of that. Right, so mahalo for that question, Richard. Let me get us back to our images here. Okay. All right, zooming in on that Hornado once again. Telephoto image of that degassing Hornado says each is several tens of feet tall, less than 30 meters, and is fed by lava tube network beneath the solid surface crust. So there's that larger one. You can see a small one here in the background, small one over here as well. That might indicate a little bit of the tube system's pathway across the crater. Another photograph. This one is of the island that formed December 2020 and then spun around and has now been rising with the crust. We mentioned a few weeks ago that this island appears to be getting smaller because the lava has been onlapping onto the edges of it, right? So that's interesting in and of itself, because we've talked about how this whole crust has been buoyant, and that's been a little bit of a surprise, as normally the lava would come up and overflow and rise to the surface here, right? But we haven't seen that. We've seen that the core of probably what's below this island, which we saw was formed early on in eruption, the first couple hours of December 2020, and likely has some core of a lot of tephra, big gas-rich rocks that occurred from that original high fountaining from the first opening of the vent. That lava interacted with a pond of water that was in the crater at the time, and then was probably coated in some kind of shell of lava to kind of allow it to stay coherent to some degree. I would expect something like that, right? So there's something like that underneath here that's keeping this crust buoyant. But interestingly, it's not as buoyant as before, because you can see that it's not rising as much, and lava is able to come and onlap onto the edges of this island as well, right? So it's interesting because as lava is depositing, you get more and more lava on this upper piece of crust that's floaty, then its average density is changing, and eventually it may become not buoyant, but it seems like it's still doing a pretty good job of floating upwards, right? So interesting to consider that might happen at some point, but do some math, figure out when or if we might even see it. Next photograph is looking at Mauna Loa in the background of Kilauea here. So there's Mauna Loa on the horizon, Kilauea's lava lake surface down here in the bottom right. Zoom it way in, you can see there's a piece of the road beneath the edge of the cliff right over there. And you can see this westernmost down and drop block as well, carrying the old 74 fissures, southwest rift area. Topic for another day. That's the last photograph from that batch, and there is actually another batch, which we'll turn to here from July 13th. And this one you can see more of the fume because it was quite rainy. We have an image of the West Vent cone down here, and a measure of its height, 24 meters, 79 feet tall, reported by the USGS. In the caption here, photo taken by El Desmither from the West Rim. The lava lake is actually, in here, measured to be about 9 meters or 30 feet below the crater rim, right? So if in case you were wondering, how tall is this ledge here on the side? That's about 30 feet, 9 meters. It's dropped down as of yesterday. Here is the scientist using the laser rangefinder to measure those areas. And as you can see, they're measuring not just the rising in one spot like we have from the graph, measuring all the different spots all around and giving us heights. And they can track how the crater might rise unevenly in certain areas, whereas we're just kind of getting an average representative value from that one data point. Pretty cool. And here from the western rim, during a break in the weather, you can see all the different fuming sources across the crater floor. The main West Vent complex being over here, but clearly fuming sites along where the lava is starting to interact with the ledges on the side, right? So this western ledge that's down dropped. See some steam coming up here. See steam coming up along this northern edge over here where the lava is coming across that block, right? Imagine that these pieces of land probably have more water in them right, than the areas where the lava is already filled in. So you might get more steam in those areas. And of course, from the actual crater itself, if I zoom it in, from the actual crater floor itself, there is that old north vent island fuming profusely, another area that's sticking above the lava and can perhaps take more water. And here across that whole back eastern part of the crater floor, all steaming as well. This is that what I was talking about as far as seeing everywhere that's hot after the rain, right? Even this downdrop block cliff is steaming in the background here. So pretty cool stuff. All right, that's the media roundup. So we will finish off our first half of our update here by looking at the earthquakes and Mauna Loa. So let's do that quickly. Not a whole lot of action, but it's worth mentioning as always. So here's our recent earthquakes for the last year. On Kilauea first, and still at low levels on this year-long view. On a month-long view, nothing to see there, pretty average as well. The map for the last week, you see these events near the summit still occurring at low background levels. South flank still active as well, but actually at quieter levels than we're used to seeing, so it seems pretty slow as well. And we're getting a few of these deep earthquakes still, but a little less than before going on. There's in cross-section happening here, and these deeper events. Of course, Pahala still ongoing over here. No real change in the pattern that week. Right, so for the last month, a little more populated, a little clearer picture of that summit activity and south flank activity and Pahala activity, as well as the deep stuff that you can see all through here. So that's Kilauea. We'll turn to earthquakes island-wide. Here's the map, and there's a Pahala cluster in the south right there. Kilauea, this whole area is actually pretty sparse. Mauna Loa, still having earthquakes in that northwest quadrant, and a few events at the summit, some events on the flanks still, right? Here's for example, a 2.1, all the way over here, 0.6 flank earthquake, so probably still having inflation and filling of the mountain, and ongoing sprawling of the volcano, right? In a non-threatening way so far. Still at alert level yellow, but showing no real change in its pattern, you know, as we see now. So we'll focus Mauna Loa here slightly more, but just to mention one earthquake all the way over here, not that far from Hilo, 2.3 as well, deep one as well. So that's it. Couple around Alihi, 2.6, 2.6, but overall, everything falls into the expected pattern. Nothing really alarming there. Mauna Loa, earthquake rates on Mauna Loa. Here they are for the past week, or past year, I'm sorry, with earthquakes per week as the measure. So we actually climbed from, call it 30 earthquakes per week to about 100 earthquakes per week over the last month or so. So the rates have been rising slightly. Zoom it in so you can see that a little better there. 30 to about 100, right? So rising slightly. But you can see we've had a little short-term variations. We've had earthquakes above 100 per week before without any consequence, even larger spikes than this. So we'll just keep track of this and see if it leads to anything more. But just a short-term small variation so far is all there is, but worth mentioning. GPS north to south of Mauna Loa, still also steadily extending. The line seems to be going upwards, even if slightly on average, with quite a lot of variation up and down as usual. So nothing really alarming in Mauna Loa. If you start seeing it go like that, that's what's been going on. Okay, this all comes from USGS, so once again, a big mahalo to the USGS for all this data, webcams, information, images, everything that we're sharing with you guys. We're just repackaging it. And here is the most recent update, so you can see advisory status, color code yellow, not erupting, no significant changes. And that's essentially it. Elevated seismicity above background still. 87 small magnitude earthquakes beneath the summit upper elevation flanks, mostly at shallow depths less than 9 miles below sea level. So all that is standard. But while we're in Mauna Loa, it's worth mentioning when I bring up this camera. This is the KP camera Dane caught last week. looking from the end of Mauna Loa Road down towards Kilauea. So this is the glow of Kilauea you see right here. Now I'll zoom it into this area right there so you can see a little better. Right, and what you'll notice is that there's actually volcano glow, and you see this other spot of glow popping up right in here. That is the fire occurring. So you can see it flares up where it's very bright on the camera early on, and it comes and goes. You can't see this easily on a webcam, but it is still ongoing as of right now. I can share with you guys this wildfire update from National Park issued today. Actually just a little more than an hour ago. So here's the fire responders mopping up the fire up there on Mauna Loa Road. The power line fire, as it's called, is 90% contained, remaining at 42.5 acres in size, so pretty small still. They were aided by periodic rainfall Wednesday and overnight, and were able to surround the perimeter of the fire and douse residual smoldering flames with nearly 2 miles of fire hose. Today they're going to try to get to 100%, and you're using water, chainsaw, hand tools, and all of that. They're investigating cause and origin point. First reported at 6:09 p.m. Monday, July 11th. Dane was right on it. Saw that camera image right away. I believe 2 Pineapples was streaming shots of that fire as it's going on. Missions are still dry. Share some other images from the park that have been released. So here's an image of that fire. You see the embers flying in the air there early on the 11th.
Yeah, that the 11th was like, if you replay the time lapse, you can see it happen like in the around 6 to say 10 p.m. That fire is getting fed heavily by the winds, which are on the normal trade winds, but they're pretty strong. You can just see how much that wind is tearing all that smoke across. And then around 10 p.m., it just gets smothered by the smoke as the winds die off. And that really kept that fire down, because we were wondering how big it was going to get overnight. And then to see that smoke come in and sit on it all night long, that was big, for getting that that initial jump on the fire to be able to contain it. Yeah, there was one other thing. There's damage up here from previous fires. Fires up here are not uncommon. This is away from the summits of the both volcanoes. So one of the things when 2 Pineapples and I were talking about this when, it was going down at the very beginning, and we both were like, it's a fire or something weird going on, right? We both were like, it's not the volcano. But if you went on Twitter or something like that, you would have seen plenty of people that are like, oh, it's a fire or it's a volcano. Well, this isn't really the spot you'd be looking. There were no earthquakes, right? So I was considering a helicopter crash before I was considering a volcano type thing, another eruption. But yeah, it's interesting to see it right in front of the camera. We don't have a ton of cameras looking down from Mauna Loa to Kilauea, but managed to catch one.
Yeah, pretty cool catch there. Yeah,
and that one other thing that was cool about this is that the webcam was one of the first things that was seen. Like, there was people that were seeing the smoke too, but were reporting it to authorities like, hey, it's on the webcams. We can see the smoke. What's going on? So, having these things is, having webcams is not a bad thing, especially when people monitor them on the civilian side.
Crowdsourced monitoring is our thing. We like that. So see something on a camera, let us know too. Just like this fire popped up, yeah. There are some other park images here, so let me play you guys this park video, the smoke back here on early on, right? Let's see what day this is. I'm not getting the date here. Scrolling. There is a view at sunset, that fire. And some of the damaged area there. We'll have to look at an ad here. Let me skip the ad. There they are, winding the hose. Some of the area that's been burned, what it looks like. Burned koa tree, acacia koa. Thornless acacias, wattles for you Australians. Some more of that burned area there. Smoldering, let me play this so you can see what they're dealing with now today, kind of what the mop-up might look like. just a few spots that are still smoking. You see that dead tree. It's probably burning right at the soil level right there. One spot of smoke. It pans around, another one. That dried dead tree. So there's some more in that fire. Yeah, interesting. You know, people are obviously worried about the volcano, but I did hear someone actually ask me what was happening in Mauna Loa if Mauna Loa was erupting, and it was the fire in the end, right? So one more video here. Chainsaw work. Sorry about that noise. That's on the video. And down a little bit. Might have been a little late. Okay, so there's a next one. Oh, nope, more ads. But we appreciate the park sharing these. There is chainsaw work. Mopping up. That's what a mop up looks like.
It's a hard job to get those last embers out. You know, going from 90% to 100% contained, that might take a day or two. It's that hard digging, and you got to do a whole bunch of busy work to ensure that it's actually out. It's so easy to restart with those embers hidden under the ground.
Yeah. Today being dry, yeah, that's. Look at that hot rock just put out of there, right? You can see how that goes, and maybe the rain that comes over the weekend will help them put it all the way out if they haven't got it nailed by then.
Right.
Another image there, and finally the map where this actually is, right? So here's this green is the park boundary. This right here is Kipukapua Ulu, often known as Bird Park. We can zoom this in for you guys, right? This Mauna Loa Road off the highway. Highway 11 would run in this direction, but farther over that way. Yeah, so you off Highway 11, come all the way in, past a picnic area, Kapua Ulu, commonly known as Bird Park, right here, and then a gate that goes up Mauna Loa Road is usually right in here. So up the gate, past Kipuka Key, which is another ecologically sensitive area, and then up here, Powerline Road, right, on the Mackay side of the road downhill is where that fire is, right? And see here, this is a edge of a lava flow right in there, so that probably helps to form a natural barrier fire right there. So that's that's it on the fire. Let's see what we got next. Next is our community corner before we turn to our questions and midpoint break. So let's do our community corner real quick here. The first thing to mention is that next week will be the virtual public meetings, July 21st, held by the National Park. The comment period is open all month, July 1st to 31st, and this is community input on the environmental assessment, EA, for the proposed recovery actions at the national park. Essentially, there's all kinds of things that are listed here: deconstructing Jagger Museum area, repairing those bathrooms, restoring access to that overlook, constructing a trail, replacing the water tanks, making a new fuel facility for USGS over near KMC, replacing the visitor center, adding more parking, repurposing the current KVC visitor center for special events, redoing the park entrance, realigning the roads, putting in a big roundabout. It's kind of like a laundry list of stuff that's been needed to be done for a while, and then when the eruption came and destroyed much of everything, it gives you a good chance to iterate it all and step it forward. That's what's going on here. And we will feature more on this next week. We'll see exactly how we can share that with you guys. Perhaps we can bring you the public meeting, or we'll get back to you on that. But in any case, we'll share about that more next week as well. But this is ongoing. That's our first point on Community Corner. Second point I want to mention is Experience Volcano Festival is coming up in about 2 weeks up here in Volcano area, July 30th and 31st. That's Saturday and Sunday, 10 a.m. to 4 p.m. And this is a pretty unique event. What they do is they have all these different businesses across all Volcano area have different kind of stations with different events. So, for example, you have Ohelo Cafe over here. You have Cafe Ono and Volcano Garden Arts. You have Lava Rock Cafe, Kilauea Lodge, Volcano Winery, all the way back over here. You have the Art Center. You have Akatsuka Orchids way at this end. You have KMC, the Lava Lounge and KMC Theater. You have 2400 Fahrenheit Glass Studio down here. And some food trucks, Tuk Tuk Thai food truck and Auntie Pon's Thai food truck over here at Cooper Center as well. Extra parking where it's yellow. All these different areas. I'll show you one more. These images. This is a schedule. And you'll pass these out when you get there, and you can actually have it stamped at each location. And if you do that, you can enter to win the grand prize, right, by leaving your map. But here's kind of an example of how it works, right? You see examples of each location, Garden Arts, Lava Rock, Kilauea Lodge, and all the different things occurring there, right? And labeled whether it's live music or Hawaiian cultural events, things like winery tours, there's a glass blowing demonstration, tea workshop, historic homes of Volcano walking tour, tiki crafts, all kinds of stuff going on. I won't go through any more of it right now since it's still 2 weeks away, but check this out. Experience Volcano Festival coming up. This is our second community corner point here. The final one is what happened last week. We streamed for you guys last week. This helicopter survey over Kilauea is still ongoing. We will actually be recomposing that presentation and releasing it separately with cleaner slides for you guys, hopefully by the end of the weekend here. But there is this website, which I'll pass it to Dane and maybe he can drop it in the chat for you guys. But that link is where you can find the most recent updates. They're updating this page every day with whatever is changing. So for example, when you scroll down here, what you do is you click on this big overview header. It opens up, you scroll down, you can go past this data over here, scroll down to where I'm looking for to show you guys right now is this activity timeline right here. So they actually had some technical delays. So let me see if I can make this larger. A little better, maybe. So they were scheduled to start earlier, but they had technical problems and have delayed it. So tentative start on July 14th. They were going to fly one of the first 4 lines, but actually today they came back down here and updated just today that they were no longer flying flights 1, 2, 3, and 4. They're postponed. Instead, they're flying the 2 farthest out flight lines west to east trending Pahala area to west of 130 today. That's what happened today, most likely. And they're basically trying to work around the weather, which is why this is changing and might change again. So check that link for the planned flyover dates, right? So mostly they're flying in the park area earlier, and later they'll be flying over Lower Puna later in a month. But they will be flying over all of Lower Puna. They actually will stop if a car is coming to not fly over any car or any people. They'll go around all the houses that they can. So they're trying really hard. That the actual instrumentation, not putting out dangerous emissions or anything. So it's all that's recapped in the presentation that we'll share with you guys once again. But there it is. After July 20th, 6 to 7 survey flights will continue in Lower Puna. 2 to 3 hours in duration with 2 flights likely per day, weather permitting. And these are only like 9 a.m. to 4 p.m., so just daylight hours. But here's where you check for those updates. And here is the updated map showing all his flight lines, right? We showed you an earlier map that didn't have this full extent, but all the way from Pahala outside the park, all the way to Kapoho in the east, that whole area, you can see all these green lines. A little more, you can see, maybe see them a little better. Right? All of that is being. It looks like they're not flying directly over much of that lava flow or inhabited area where they can help it. The flow itself may block some of that, what they're trying to sense, but we'll just wait and see what they put out. All right, so that is it for our community corner today. So with that, we can say some mahalos, and I'll bring Dane back on here to lead us with that.
All right. Well, do want to thank everybody that turned out today. We rely on the viewers like you. Make sure you're subscribed and maybe drop a like. That really does help the channel. Subscriptions are free, so if you don't like it, you can always unsubscribe for free. We do these presentations every Thursday, unless something comes up, and then we'll go live, but usually Thursday, 5 p.m., unless technical difficulties like today. Want to thank those that showed up in chat with the super chats to support us, some longtime supporters. Judy says, with a $20 super chat, rocking it as always. Thank you, Judy. And
Judy.
Yang Zhao has a question for you as well. We'll get his question in first when we get into the questions. Do want to thank our longtime supporter, Kilauea's Bar and Grill, as well. They got 2 locations, one in Pahoa, one in Orchid Land. We did have a comment from a viewer. Want to mention that. Hari Gupta says, went to Kilauea's Bar and Grill in early July when I was visiting Big Island. One of the best Mai Tais and food. Awesome. Yeah, definitely let them know that Hawaii Tracker sent you, and we appreciate their longtime support. If you're looking for what day is best there, I would recommend the Thursdays because Kaika Marzo's band and everybody that we used to play down Kalapana kind of gets together there and plays now. So definitely make a reservation for that one because tables get kind of booked quick. All right, I think we can get into some questions now. We do have a decent amount of questions. Did say we'd do Yan Zhao's first. He asks, how deep is that volcano to the south, the Big Island, and how often does it erupt? So he's talking about the volcano formerly known as Loihi, the new name I'm not going to attempt to pronounce yet.
Yeah, so it's I maybe should look up the exact numbers, but it's something like 1,000 meters underwater still. It's still a good distance below sea level, but it is a long way off the seafloor, right? So it's maybe 3/4, 90% of the way to the ocean surface from where it actually sits. Its last eruption was 1996, I believe, right? But it's had some other earthquake swarms that have come through there. Which may be intrusions, and the thing is, there's a chance it can have a small eruption if it doesn't have the quite all the signals you expect, because we don't quite catch everything from land, but they do send a submarine there usually every year. And
right.
We haven't seen
most of our information that comes from it is by proxy. Kilauea and Mauna Loa, like we can see it from there, what's going on, but we don't have active monitors at the bottom of the ocean.
Right.
The tilt meters, the GPS, all that kind of stuff, all the fancy stuff.
Right. We'll mention that later on, that there is a study that put out ocean bottom seismometers in 2018. But those kind of things are usually temporary.
Right.
You got to drop them off, and you got to go back and pick them up afterwards. You can't leave them there all the time, and it's kind of a as needed kind of deal. So if he were to start showing activity, they might go out and deploy some, but there's been no need. Nothing like that's happened. It seems to be pretty mellow right now. We have seen lots of earthquakes in recent years, right? So it's probably had magma movement. It might have had intrusions, but no confirmed eruptions since '96.
It would be cool to see something like a deep sea or an underwater Raspberry Pi solution for a seismometer that's able to somehow penetrate the water with some kind of signal. But maybe someday. Not today.
So much water.
I know, it's so much.
Yeah, so that's why.
That'd be a nightmare.
Yeah, I mean, at one point they had a wire, a cable going off the island, right?
Yeah,
down to the instrumentation down there, right? So, but something happens to the wire, then you have to go and rescue the equipment, and
no fun.
So, in any case, it's tricky. Yeah. It's tricky, but yeah, if something major is happening and if earthquakes occur, you can see them from land too. But so far, only minor stuff in the last 30 years, 25 years.
Yeah. All right. We do have a question here from Adria, who says, is the volcano cone in the ocean growing too? So back to the volcano formerly known as Loihi, or do they monitor it from the ocean? So is it growing? Is there, I guess, it goes back to the eruptions, right? And it's usually how we attribute growth to these volcanoes, is it erupts.
Yeah. So
what's your thoughts?
I mean, the '96 event, I don't have it fresh in my mind, but I believe there was, they saw changes in landscape for sure, right? I think they saw some lava flows on some sides and possibly some pit craters open up as well, right? So it did seem like it grew and collapsed both, based on submarine surveys before and after the event. So it is changing. It's not, it's one of those eruptions kind of happen that you see it. rather than all the time, right? And that volcano is actually officially now named Kilauea, formerly known.
There you go.
That's what I'll do.
I'll get the pronunciation, the confidence on the pronunciation eventually.
Yeah, I butchered it so bad the first few times. So even trying to read a pronunciation.
I mean, you're braver than I am on it.
I misread the pronunciation guide, so thanks for helping us get it here. And here it is, properly spelled and maybe not properly said, but there it is. Kilauea.
All right. Next question is from Joseph. He asked, it seems that the lava will go into the next down drop block. Is the correct 2 to 3 months it gets to that down drop block? Is that kind of the timeline, I guess, that we're looking at?
Yeah, that's about my estimate. I haven't recalculated it with the most recent values and the recent depth from today, but my calculation from
close though.
From a couple months ago is, I think, it's still fairly accurate within its error, right? So
yeah, definitely.
Yeah, that's the
latest. All right. Mark asks, is it still best to go at 3 or 4 a.m. to see the lava lake?
That is my preference.
I know that was like that. Yeah. You're going to avoid the crowd for sure.
It's less busy for sure. It's quieter, right? Like, there are signs around for people to rotate and let you take a look and to be quiet and all of that. But when there's more people, it's just hard for that to happen. So when you go in the morning, you have a better chance of actually hearing the vent make sounds. It's early, people are more tired, I guess. People are naturally more quiet. And then, walk back in the daytime in the sun. Maybe not too sunny, but right now you walk back in the daytime. So it's easy thing to do, apart from the early wake up and getting out the door. That is my preference for sure, especially at Kinakakoi Overlook. Kupina'ipali seems a little less crowded even in evenings, right? And there's more parking there, and it's like less risky if you get there, and it's not great. You only walked a quarter mile to get there. So, if you have to go in the evening, I would still recommend Kupina'ipali. And if you want to go in the morning, you have your pick of what you want to do and where you want.
Right. Always the Wolverine's Ledge is great stuff if you want to go check that one out. Easy access. Not very popular.
Right. Yeah, that's what I'm calling Kupina'ipali, is aka Waldron's Ledge. Yeah. And there are signs from the visitor center all the way there, so easy to find.
Oh yeah, it's easy to find now. Short walk. Kimberly asked, what's the average output of VOG per day this past week? Kona has been having some incredible sunsets, even more amazing than normal.
Average.
So to explain that a little bit, while you find that, just explain a little bit. So the 2018, the VOG was, heavy on the Kona side, and it would create these very surreal sunsets where there's a bank of offshore bog. It's foggy in Kona too, but there's a bank offshore as well, and you're seeing the sun pass down behind it. Mm-hmm. And in 2018, the sun would disappear behind the bank before you even get across the horizon. It was that thick. But when it's thinner, you can get some interesting play on the light kind of thing.
Yeah, so
makes for good photos,
Yeah, for sure. Yeah, it's like similar to that kind of smoggy sunset or that kind of thing.
Yeah, you can get the right effects on it, type of thing. It makes it look trippy.
All those particles will disperse the light in an interesting way. So, but yeah, the VOG has been, for the last week here, the last 3 measurements have been in this 1,000 and 1,500 range, maybe more like 12, 1,300 or so. So it's not been that unusual, really. It's not any extra. It's not really that much less. It's kind of where it's been, right? There are a couple of days, right? Like over the weekend, maybe there was extra, and in this gap over here there was extra, and then over here in this gap there was extra. So there certainly are pulses, and depending where you are, you might get a more intense effect. But there's no huge jump in the emissions overall.
All right. I did have a question myself. Looking at that little crack that was emerging inside the circular crack inside the solidified lava lake.
Mm-hmm.
It almost looks like the beginning of a bench of some kind. like that inside is flexing and you're getting that lava coming up in the weak point, stuff like that. But that bench is, the lines of it have almost been drawn of where it's going to emerge. What's your thoughts on that?
Yeah, we've seen those cracks in that area doing exactly what you say for months now. So it's just one different angle of a different view of a crack that's, and the thing is, imagine as the lava comes up in those areas, it's going to come and kind of come up right against the crack or possibly cover that crack again. And then it's going to break it's going to reemerge through the new flow. And so you can see them a little bit more, a little bit less, depending on what's flowed over it. But we have seen from all different angles that original crust from the beginning of this eruption being the floaty bit in the middle and the cracks around the outside, and then like a moat around it, right, of where lava comes and fills it in and like just fills that low spot in big sheets. Yeah.
All right. I think we have one last question for this round from Hari Gupta, who asks, if USGS doesn't do the EM survey over Pahoa and Fissure 8, how will they know the depth of the lava and the plumbing that led to the fissures?
Yeah, I mean, I'm not sure that they're not going to do it necessarily. There are different. So I mean, I suppose the first answer is that the airborne EM from the helicopter is just one of the data streams that they're using to figure this out, right? It combines with the magnetotelluric, the MT survey as well. And let me see if I can pull that map up. There it is. MT survey locations. So if you look at this map, there's other survey locations that go down in an area as well. So it's kind of looking at the whole region as a whole. There's not a whole lot of density right across Lake Lining by the looks of it here, but you see two stations, one on each corner of it. Get some idea there. So yeah, it's a good question. We'll have to just wait and see what they can measure. There are limitations with every technique. If they find certain kind of resistivity, they can see deeper and they can see shallower other times. So, kind of everything varies and just see what you see. And so I'm sure they'll fly over what they can, but they may be trying to avoid flying over houses directly.
Yeah, but the way they defined it, like when we were talking about it, the not flying over houses and stuff, the map, we already changed and it kind of is weird. To the point where I'm almost like, I think the way they defined it means they would fly over Fissure 8. Because there's no houses right around it. You could easily get over the thing. You can get all in that part of Leilani without going over any houses.
Right.
It's harder to weave in other spots that they show that they're flying. So it's like, okay, well, they're probably flying this then. It just doesn't show it on the map.
Yeah. We'll wait and see, and maybe that's the case.
Yep, we do have one last $25 donation came through on hawaiitracker.com. We do accept donations there as well. Check out hawaiitracker.com. It's our backup for where we post everything in chronological order. Lisa J made a $25 super chat there, or $25 donation, and we appreciate that. All right, back to you. And if you have more questions, we will be doing one more segment of Q&A, so go ahead and get them in.
All right, so what we'll do now is we'll transition to talk first about Volcano Watch, and then we will switch into 2018 and research Roundup, which this week is all 2018, in fact. So let's show you guys Volcano Watch. All right, so this week, Volcano Watch, what is a volcano? This might seem like a pretty basic question. This is a topic of a Volcano Watch 20 years ago, so they have seen questions from recent visitors that have prompted them to revisit this issue, right? So, view of Pu'o'o 2015, and this is a question that often comes up with Pu'o'o. Is Pu'o'o its own volcano, or what is it, right? So we often say, well, Kilauea is the volcano, and Kilauea has many vents, and one of those vents is Hale Ma'u Ma'u, and one of those vents is Pu'o'o, right? So depending on your definition, it says here that dictionary, it could be any vent where the lava is thrown out, but really for geologists and volcanologists, that's not good enough, right? Really, it has to be some kind of deep structure with a deep source. Generally more than 18 miles deep that feeds it, right? So kind of like the big trunk of a tree. And then when it gets towards the surface, it might have branches that kind of go out. You might have each branch intersecting the surface might be a different vent, but it's all the same volcano, all the same structure, the same source, right? That is basically it. Sometimes they have terms that they'll use to describe the other vents that are off to the side from the main trunk, like flank vents, parasitic vents, rift vents, sometimes cone. You can't use physical appearance, right? When you get to the top of Kilauea, what you see is a big hole in the ground, a big caldera, rather than your pointy-topped peak that you might see at a stratovolcano. Yet from a different kind of lava than we have here, right? The lava that's stickier, like St. Helens or Fuji or Krakatau, it's stickier, so it piles up and makes a steeper edifice. It doesn't release the gases easily, so it tends to be more explosive. Those kind of places, right? You don't see that in Kilauea. Instead, you see this big crater, so that can be off-putting as well. Whereas Pu'o'o actually is above the surface, and so you might think, well, that's the volcano, not over here. So that's why they're talking about all of it. So that is basically it. You can go read that on hawaiitracker.com. I won't go through any more detail of it right there, but that's Volcano Watch this week, revisiting that fundamental question of what is a volcano. All right, so with Volcano Watch covered, what we'll do is we'll transition to our research roundup. This week, it's all focused on 2018, so we'll call it our 2018 Eruption Research Roundup. So the first article here was actually released today as well by the USGS, and Science Snippet, Volcanic Eruption, Earthquake, Stay Calm and Laugh On. So this is by the Communications and Publishing Division of the USGS, right? So what they're talking about is using humor during disasters to help people cope, right? During eruptions or earthquakes, for example. And this is interesting because this is where we're going to see an appearance by Rusty the Lava Rooster, mentioned in the USGS not Volcano Watch, but the Science Snippet this week. They talk about how we had the eruption in 2018 here, and we had all this damage and loss and suffering that occurred. But however, one bright spot was the live streams of Rusty the Lava Rooster, which USGS actually shared on their Twitter account, right? And that was a little bit of comic relief, if you will, right, of that eruption, right? And it really allowed them to research people's reactions, because some people thought that was hilarious, some people thought it was really insensitive, and others might have fallen somewhere in between, right? So they're basically announcing this research here, right? They have a conceptual model, they have cultural and location influences as some of the variables, whether things are appropriate, kind of humor, the kind of crisis, the point in the crisis, all of that kind of thing, right? So you can't like mock anything besides yourself, really, right? Self-deprecation actually works. Animals, especially cute ones, and absurdity is what they're kind of sticking with, right? So that's kind of where Rusty the Lava Rooster comes in, right? This is kind of a review of a publication, so I'm going to turn to the actual publication itself. Here it is, an International Journal of Disaster Risk Reduction, available for free online, by Sarah McBride and Jessica Ball from the USGS in California, and hashtag the S'more You Know and hashtag Emergency Cute, conceptual model on the use of humor by science agencies during crisis.
So yeah, I have some things to think about that one. So that's really nothing new to me. Like that can be done. This has been done for decades upon centuries, type of thing, with the soldiers, like the trench humor, they'd call it. It's most morbid, ridiculous stuff, but the guys there use it as a coping mechanism, and they find it absolutely hilarious. It might not make sense without the context, but that's the way they got through some crazy situations, was using humor. We saw that in 2018. You can see that in a lot of situations where things are bad, people still find a way to get through it, and humor is a good way to do it. There are constraints on it's probably good, because it can get pretty dark pretty quick, that kind of humor. But they're putting on the parameters to try and give you a good start on how to do that kind of humor without crossing boundaries, and it's a delicate art, that kind of stuff.
Yeah, definitely. Yeah, so
Yeah.
interesting parallel to the military there, right? They're trying to make it so that they, as a USGS, can use it as a almost like a policy, right? They're researching it so they can institute some guidelines to doing it in the future because they saw success and perhaps mixed success depending on how you look at it at times, right?
Yep.
So they have
Yep.
I'll scroll down here, right? They have all this background on theories and how scientists deal with humor and humor in crisis, proximity to crisis, timing, right? And like normally they say that like timing of course is everything. Someone suggests a sweet spot like could be like 8 days afterwards, right? But that might be like when you're having a 1-day event and not a 5-month eruption or something, because 8 days into it, you're just getting started and it's like not the right time. So that was kind of one thing they had to figure out, right? Like they say like their sweet spot might have been like, well, maybe 2 weeks or so, like, but no, that doesn't work here. Like 2 weeks is too soon if it's a long lasting disaster. And what kind of things are appropriate? They go through all the theory, and look at the pitfalls of like cultural humor, right? Depending on what culture you are, you might find something funny or not, but the other culture is not finding it funny, and all those kind of things, right? So I'll skip through all this kind of thing. Source of humor, communication channel, like how you deliver it.
That sounds. They make it sound really hard.
Well, they're giving all this background, right? This is all background to the case studies. And there's 2 case studies. One case study is Hawaii.
Yeah.
And here they can see there's a montage of their rusty lava rooster, right? Having its own account right here, right? Shared by the USGS. T-shirts that were made, books, right? Here's a rusty lava rooster riding a surfboard down a channel. Meme.
I never saw that one before.
I never saw the shirts myself either, but I was a little busy at the time, so I wasn't shopping for shirts.
Yeah, we were missing stuff like this.
Right, but cool to see that Rusty has now been published. Here he is published on T-shirts.
I wonder if they actually know what happened to Rusty, because the accounts I have are varying. At the end of the day, what happened? But very interesting stuff.
So that was part 1, 2018. There's more. They actually went on to talk about this the s'more, right? I know you remember this, Dane. May 30th, 2018.
That was hilarious.
Jay Fur at Jay Fur on Twitter asked USGS, is it safe to roast marshmallows over volcanic events, assuming you had a long enough stick, that is, or would the resulting marshmallows be poison? And the USGS answers, we're going to have to say no, that's not safe. Please don't try. If the vent is emitting a lot of SO2 or H2S, they would taste bad. And if you add sulfuric acid and VOG, for example, to sugar, you get a pretty spectacular reaction. That was one of those attempts at humor that some people thought was hilarious, and others were like, you're totally being insensitive. But that was picked up by all the major news networks, right? Here is CNN, here's MSNBC. MSNBC actually had the host come out and draw, where does it say in here? Let me find the actual text here. Chuck Todd, MSNBC anchor, ran a story featuring a hand-drawn explanatory diagram, a reference to Ghostbusters, and a graphical pun on their public service announcements. The s'more, Right, so reactions were varied. Some people were upset, perceived disrespect to their communities. Others cascaded the author as idiotic, and still others recognized a joke and commented in kind. So there is a case. In this case, an attempt at humor fell flat with some observers, despite occurring nearly a month into the crisis, while others recognized absurdity. It's an illustration about how even the 2-week guideline for timing may not apply universally across publics. So just a little snippet there to give you an insight of what they're talking about. The s'more, logo right there, right? And that's kind of the second one. They have one other case study that's actually from earthquake 2016, Kīlauea, New Zealand, right? So this was Wellington and Christchurch that had the earthquake, and so there were lots of aftershocks. People were really worried. I missed actually one more 2018 one, but while I'm talking about that one, so GeoNet Australia puts out the emergency cute tagline, night shift, right? And they keep putting in these cute animal pictures as a kind of a comic relief to the information that they're putting out about the earthquakes, and everyone is really worried. Bit of a shaky Sunday. Here's a dose of emergency cute to help you through. If only quakes were as cute as the coca, right? Another emergency cute. And so that was another way that they kind of were able to share things a little bit more lightheartedly. But back to the 2018, the last example was this one. The VO46 GPS site went offline in mid-July, and they say, we can confirm the station has kicked the bucket, shuffled off its motor coil, run down the curtain, and joined the choir invisible. VO46 is an ex-GPS. We referenced the Monty Python Dead Parrot sketch right here. People got it, right? All kinds of people posting memes and all of that, but another one of these examples of how they made light of losing the GPS station in the middle of that massive summit collapse. So pretty cool to see this kind of research being done. In addition to all the actual science we've seen, this is a different kind of it that's equally important because of communication. Communication obviously is our thing here. So here is their model, right? A model of successful use of humor in a crisis, adorned by Rusty forevermore. Right? Timing, very key. Appropriateness, physical or emotional proximity to the event, the type of humor, the channel, nature of the crisis, need for emotional release, and the source of the relationship, the relationship of the source with the audience. Right? Those are the kind of the keystones here that are needed. Right? With timing being the most important of all those keystones. So
I have some, if I was to add anything to here, it would be don't force it. It's really easy to try and do something and then, it completely backfire. And also don't be afraid to appropriate something. There's a good meme online, just take it. Use it.
Crowdsourcing.
These things are going to emerge. These things are going to emerge mostly organically, and it's more about identifying them and then using them appropriately, type of thing, as opposed to wholesale trying to create memes at the USGS type of thing. That ain't going to fly. That's not going to happen.
The internet is better at it. Let them do it. Crowdsource it. Crowdsource your humor.
Yeah. Don't be afraid to take it, though. When somebody makes something funny or whatever and it works, just take it and credit it. Not a big deal,
Yeah.
Yeah.
Sure. The new world, right? They're allowed to reference other authors besides themselves.
Right.
So that's the first topic of research here. We're going to move on through 2 or 3 more. One that caught my attention goes back a couple months now to May 25th, was released on YouTube by Iris Earthquake Science here. And I'm not going to play you guys a video, but I'm just going to recap. This is a 50-minute talk by Dr. Guoqing Lin, collaborating with USGS and University of Miami and Iris Scripps as well here. This was a talk given at OMSI, the Oregon Museum of Science, Portland, Oregon, back on May 4th, the day after the eruption anniversary here. So some highlights from this talk. Maybe drop this link in case Dana wants to share it. Let's see. So while I go through here, I'll share the highlights of this, at least as they were for me. So the summary: largest eruption in 2018, collapse in at least 200 years. But there were changes in the parameters of seismicity, right? This is a seismicity study, earthquake study. So the rate went from an average of 30, that's our average rate per day, to hundreds per day in that event. Seismic velocity changed, distribution of earthquakes changed, and focal solutions means whether the rocks were being like pulled apart or squeezed together is kind of how I put it for you guys, right? So I'll go through that here shortly. First, the context of seismicity. Here's seismicity back from 86 through 2018, and you can clearly see what a record event 2018 was, right? You had a couple of spikes here in the mid-90s, but nothing like what we saw here for as long-lasting, for as high as it spiked as in 2018. So looking more closely at just 2018, here it is, January to December. You see how the energy being accumulated here, cumulative number, was building up gradually until early May, and then it really accelerated. This first phase was that eruptive opening phase right here, and then this second bump is a caldera collapse phase right through there, and then post-eruption afterwards. So clearly dramatic, but cool to see that. Next, we'll look at what's the seismic wave velocity. So the way that they do this is by using what they call ambient noise interferometry. They're using the interaction of ocean waves on the coastline, creating background noise that's picked up by seismic stations inland, right? And so when you do that, you can then measure the change in the background parameters as to measure seismic velocity, for example. So here is reference from Olivier et al. 2019, showing change in velocity and date. So this is March 1st, 2018 and May 3rd, 2018, right? This is the eruption right here. And so you can see that in mid-April, mid to late April, right in here, you start to see a decrease in the velocity 2 weeks before lava comes out of the ground, right? This is, of course, important because it might be a possible warning sign right there. You see that change on that time scale like that, right? And then they actually looked at the collapse sequences themselves, and the way that this works is every single collapse sequence has been stacked. So our relative collapse is 0, and they basically piled everything on and made it cumulative, right? So you see down here earthquake count, right? So collapse event occurs like right there, then there's a quiet time, and earthquakes kind of gradually get up, they start getting pretty big, wrap it around to this side, coming up, and then pop your event and then reset it, right? So we knew the earthquake number pattern already, but up here, this upper panel is once again change in seismic velocity. So on that collapse cycle, you'd see the velocity lower and lower and lower prior to the collapse, and then rising as the collapse is about to occur. And then after the collapse occurs with a little delay, then it would turn back around. So even within a single collapse, if we were monitoring this, we could have anticipated when that might have actually happened. So interesting to have that compiled after the fact and tools for the future, hopefully. So moving on to background seismicity, this is all the way through 2008 right here. So kind of just giving you guys a little bit of the context, right? Kilauea Summit, Southwest Rift is this little arm over here, Southeast Rift is over here. The upper Southeast Rift, often called the East Rift Connector, and then middle Southeast Rift, and then lower Southeast Rift down over here. Right? The South Flank, being this whole area over here with a little Helena fault system, a little chunk right here that's got faults, like little slivers of broken ground on either side. So it's kind of floating by itself. This chunk right here is kind of just floating by itself, and it has a little extra activity as well there, right? So that's kind of how the volcano adjusts over time. You can do a cross section through the summit right here, right? And we're looking at south this way and north this way. So our rift zones are, let me zoom it in here. Our rift zones are kind of these orange arms going to the south, right? And mostly we're looking at that pattern of the conduit below the volcano coming up here. Let's see how deep that pattern of seismicity is active over the years, right? So looking still at the background, we're going to look at the south flank area, the whole south flank for Helena Fault all the way down to the lower East Rift Zone. And you can see here that these are colored. The colors just mean the year. So oranges are in the mid 2000s and the blues are back in the 80s, early 90s, right? So you can see, if I zoom it in, like, oh, say, oh, look at those earthquakes down here in the low East Rift. These are all from the early 80s and 90s down in here. And you can see more recent stuff up here to the north, 2008. And likewise over here, right? And this big line, C to C prime, this green line is what we're going to look at as our next slice through the volcano. And there it is. And what you can see here is the bottom of what we term the south flank, right? This big Tacoma. So this big piece of land is moving above, and it's rubbing down here below, doing so, especially in this westernmost section here in recent time. You see this eastern section, blue was active longer ago. Okay. This orange one, slightly above it. They're close to naturally seismicity occurring there, possibly enhanced by activity as well. And these guys are catching every single earthquake in here, so even tiny ones are being picked up. So that is the background across the summit and the flank. So looking at 2018, Now our scale is orange is basically August, and blue is May, right? And greens and yellows are in the middle, June and July. So you can see that Leilani Estates is the bluish, had all these earthquakes at the beginning of the eruption, but not as many later on. The south flank, see, it was mixed throughout through here. You can see both blues and oranges and yellows and everything. And the summit is kind of overwhelmed. You see a little bit of the blues from early on, like the rift zones showing some of that pressurization. But mostly you see it overwhelmed by the more recent collapse signals right around the summit right there. So looking in cross-section and comparing now, right, 2018 is above, 86, 2009 is below. So first at the caldera, you can see that that collapse sequence was all much shallower, right, in the upper part of the crust here. Then we typically see earthquakes volcanically deeper down. There were some deeper down, but they were early on as the eruption was beginning here, mostly shallower in the summit. And interestingly, on the flank, where we had only seen one lineation with bottom of the south flank here, in 2018, we see two. There's that same lower one, but there's another one activating here above it, right? So what's going on there? Well, they found this very interesting as well. Circled it here in their cross-section, and here is what they believe is going on, right? So we've talked about how Kilauea is being pushed by the rift zone, and that south flank is catching the earthquakes at that deeper rate right there, but I mentioned this little sliver above as well, and that Helena block right here is thought to have a second zone that was activating during that time as well. So there it is. Let's advance here. Finish off this earthquake story. So before the eruption, looking at this area of faults in the Helena system right over here, right? Now they're looking at what we're calling the focal, right? And so heard of normal faults, or strike slip faults, or reverse faults. That's what we're basically measuring. Like a normal fault is occurring when the rocks are getting pulled apart. That means the breaking motion is pulling apart. The strike slip motion is when they're sliding past each other, one past the other. And reverse is when they're going together and one's got to go over top of the other. That's that reverse motion. So getting squeezed together or getting pulled apart is what we're looking at right there. So red being pulled apart early on, before the 2018 eruption, you see these earthquakes in the Helena area are mostly pull apart earthquakes. And if I advance it to during eruption, you see that they all turn blue actually, and they become being pushed together earthquakes, right? They're changing from that normal focal mechanism to reverse focal mechanism. So I've actually gone and plotted this, right, over time. So 2016 through 18, and everything below this line is normal. The middle zone is strike slip, and the upper zone being reverse, being pushed together faults, right? So you can see that for 2016 all the way through early, actually it was late 2017, and actually before the turn of 2018, you start to see a change from normal pull apart faulting across to sliding past and all the way up to the getting squeezed together, right? And really for the remainder of the time, it's bordering here between getting sliding past and squeezed together. Now, if you've been following us for long enough, we've talked about how there were earthquakes in the upper East Rift Connector, and the Southwest Rift for a couple months before this occurred. So this is no surprise to us to actually see this pointed out, but this is one measurable thing you can get out of those earthquake patterns when you say, okay, it's been quaking. We were saying something's getting ready to give. And this is how you can plot that in data apart from just earthquake counts and looking at the mechanism of whether they're pushing or pulling apart. And to put this back on a map, where's my map over here? Right, so when you don't have that much pressure in your East Rift, these can basically just be pulled apart from the line above, like kind of gravity being the driving factor. But when magma is filling the whole summit region and the East Rift Connector, Upper East Rift, and the Southwest Rift as well, then you start having it giving it more push, and then you start having these pushed together earthquakes essentially. That's how it's simplify it for you guys. Maybe I'm playing it a little too much, but that's how to make it, I think, accessible for you guys to understand it. best shot there. So that is the earthquake study, and interesting to note that there are many ways to detect, once again, like whether it's changes in the actual rate, changes in the velocity, changes in distribution, whether it's single feature, two-layer feature, and then the actual focal solutions, right, whether they're being squeezed or pulled apart. All those are things that were changed in 2018 with the seismicity that now, with the hindsight, we can design monitoring for the future and monitor all those things going forward. So that's one of those science lessons learned. That's the earthquake study. We're going to move on now to another study. This is by Josh Crozier and Leif Karlstrom. And this is in Science, another article here on 2018, but kind of the whole summit lava lake from 2008 to 2018 building up to the eruption. And they're essentially looking at magma oscillations in a shallow conduit, right? So these are almost like very long period vibrations or oscillations or vibrations, that that kind of thing. So to give you some idea of what they're talking about, here is like a model. Right? They have lava lake in that upper pit up here, and you have higher up on my screen. So Kilauea reservoir below, but there's this thin conduit between them, and this is what resonates, right? So when you put fluid through a narrow space, it's like whistling through the gap in your lips or blowing through a flute, then that fluid can resonate and create a vibration, right? And that's what they're basically measuring, and it changes in that vibration over the course of the eruption. There's one other thing that I wanted to just point out as an aside. To do that, they're integrating all kinds of other data, including GPS here, right? And one thing that we've been talking about for a long time, which is cool to see actually put here in the research, is we talked about how that summit signal, right? This Uekahuna, for example, is crater rim. Both of these are actually affected both by the crater swelling from magma coming within it, but also the south flank is moving away from here. And the south flank adds somewhat to the signal. So they've actually on here, for the purposes of their model, corrected their south flank signal, right? So you actually can see in red the true signal as it was measured, but they've corrected it for the south flank motion to get a more absolute signal here, right? So interesting, we've talked about that a lot, but here it is validated one more time in research to share with you guys. So finally, the results. There's a lot of stuff on here. It's basically going from 2010, 2008 here to 2018. And they're measuring things like the number of very long period events, right? So that's the blue, so you can see more and more harmonics occurring, vibrations occurring along that conduit right there. Here is a lava lake rise over that whole course of that eruption in blue here. This middle panel here is magma reservoir pressure, as it's modeled from the GPS inversions, right? So you can see here, they actually have two lines. I'm going to zoom into this one. The black one is Halemaumau, and this orange one is South Caldera. So you can see here that early on, the shallow pressure went up first, and then you can see it starts rising, and a lower pressure, there's an eruption. So this green line indicates here in 2011. This is that first breakage at, what was this, Kamomoa, yeah? And then you can see that Halemaumau comes back up, and a slow rise begins of that South Caldera. Right? Halemaumau reservoir starts increasing more and more, despite further eruptions occurring and intrusions occurring here. And really, what I wanted to show you guys is how the South Caldera, basically Halemaumau reservoir looks like it's close to capacity. It's almost flatline. It is rising a bit here at the end, but really it takes over the South Caldera, building up more and more and more and more and more and more. This is what we mean by that long buildup of magma that's occurred over the 10 years, right? So in the first few years, it built up more in a shallow, right? Maybe the first, call it 5 years. And in the second 5 years, it built up more in the deep, which is cool to see here, right? And, measuring other things like magma properties, try to inform their other parameters as well. So that is one more piece of research here out of Science, and we'll do one last one before we wrap it up here. And this is an improved catalog earthquake catalog during 2018 eruption from combined onshore and offshore seismic arrays. Here's where they're pulling in the ocean bottom seismometers, or in their lingo, OBS. Yep. So this is by Xiaozhou Wei, Yang Shen, Jacqueline Kaplan Auerbach, and Julia Morgan. And this is out of Rhode Island, Western Washington, and Rice University. Collaborators here. And essentially they're improving the catalog by pulling in not just the HVO data that was monitored in real time, but more beyond that, right? So here's a map of HVO's seismic network, which is basically these white triangles. Then you can see they've added all these other stations as well, including these stars that are underwater offshore here, right, to kind of help augment the network. Plus, they deployed seismic nodes. They deployed temporary stations down here in the Lower East Rift Zone. So all of that is integrated here. They deployed these Raspberry Pi seismic shakers along the roads, road areas here. So all of that was pulled together. And the long and short of it is, let me see if I can scroll down here to graphs. Well, let's look at the map first here, right? So on the left is the HVO catalog showing how many events they're showing. They picked up here, but because they have more instruments to help inform what's real and what isn't, they've essentially quadrupled. There's 4 times as many earthquakes in this new catalog than the original catalog, right? So when we talked about how many earthquakes occurred in 2018, those are all based off the HVO catalog, that 70,000 number. But if you go and actually pull in data from ocean bottom seismometers everywhere else, then we're talking about it was really like over 200,000 earthquakes at the summit, and altogether over 300-some thousand earthquakes.
And that makes a lot more sense with what we were seeing on the ground. I don't know if you remember it, but there were times where I was talking to people that were, in the Leilani on the rift, and they're like, the ground is constantly moving right now here. Like we just had another earthquake. We just had another one. And I'm like, I am not seeing anything there on the catalog. Where you are specifically, I'm not seeing anything. And he's like, no, it's right under me type thing. And multiple people talk like that. Now, with this catalog, those points would probably be nearby type of thing. Those missed ones.
They have over 300,000 with magnitudes, even if they're very small ones. And there's a few more that have no magnitude. But the real trick is, if the ground is shaking all the time, how do you separate the end phase of one earthquake from the start phase of another earthquake, from some reflection of a third earthquake that occurred somewhere else? And that's why you need more sources and more geographic distribution to inform, right? Because if you have somewhere farther away, then you can actually say, okay, that signal, if there was like a second earthquake, it should have been picked up at the other seismometer on the ocean bottom as well. And if it wasn't, it wouldn't be. So then you can do more correlations that way, and that's how you can end up fine-tuning and improving your catalog that way. Here's their zoom in on the summit and Lower East Rift from HVO catalog, and in comparison, the new catalog showing just what Dana is talking about, really big, massive numbers of earthquakes in addition to what was in the catalog there.
Yeah.
So yeah, that's fascinating. Here, here's their frequency. The whole period, the USGS had 66,760, and they're at 308,017 events for the whole period, right? And you kind of break it up prior, post-eruption, and during eruption. During eruption, actually 60,000 from the USGS, but 280,788, the new number from this new study. So fascinating stuff there. They actually have gone even further, right? Let's zoom in on these little graphs here. So at the caldera, they've done these with respect to the onset of eruption. So eruption is at day 0. So you can see that there were some earthquakes building up the caldera before the eruption began here, but really it was not when eruption began, but about 20 days into it is when the collapse sequence began, and it kind of peaked about 40 some days into it, and then it dropped off there after 90 or so, right? That's the caldera. That's 279,000 events, 179 events at the summit, of which 50,000 from the USGS at the summit. Kīlauea fault zone, just to the south, we're looking at with the previous study. You can see it was active at the very beginning of the eruption, right? As we know that was associated with that big 6.9 earthquake. Kīlauea, you can see the black is HVO, right? So the same patterns are there, but there's some more detail. So you can see HVO's pattern in black, Kīlauea spike, and then dropping off. But here you see actually more detailed. And when you have that big resolution, you can actually now see, after eruption is over, the rise in seismicity around Kīlauea coming in here a little bit, which we saw and noted at the time, right? And discussed whether it was settling or further intrusion, right? And we know that the rift zone has filled slowly over time. The lower east rift zone not showing that pattern. It does show more earthquakes at the end here, but you can see the spike here at the beginning of the actual opening sequence of eruption, and then a 6.9 earthquake and aftershocks sequence, and then followed off by a fall off. They also go over to the south flank and show that big earthquake and then its aftershocks in the south flank actually died off fairly quickly within a month or so. Lots of interesting things there, lots of interesting details from this paper. Let's see if there's anything else to show you guys in here. I think that wraps it up.
Wait, there's one thing I wanted to ask you about there. Since they're going into such precision on these things with this analysis, are they able to accurately remove rock falls from Pu'u'o and Halimamau once they drained? Because we know that there was some rather significant falls, especially around the quakes type of thing. So they're able to correct for that, yeah?
I don't remember reading that detail in there, but earthquakes and rock falls have distinctively different signatures automatically. So even an HVO catalog should have separated those successfully.
All right.
Yeah, there's one.
The one thing I did want to point out is,
go ahead.
Before you go on the lower east rift zone one, the days that I was talking about there, you can see it almost going, the new catalog going sheer vertical, while the other one looks like it almost got overwhelmed. Like, because it's tracking up on day 0, and then it just plummets off, and it's like, no, there's more earthquakes now than there was yesterday, type of thing. But the catalog was
right on a new catalog, but the second peak is lower in an HVO catalog. Yeah, good observation there.
Right.
Yeah, so cool.
And that was exactly the points where I was like, this thing isn't working almost, like, freaking out in those early days. Like,
right.
Right.
So these are the ones where you're probably picking up a lot of the smaller events that are kind of overwhelmed otherwise, where you can actually, when you have a farther away station, so you're almost filtering out some of the noise, right? Because only the strongest signals make it farther away, right? So when you're having a station far away, you can then say, okay, well, here's like the real signals, the real pulses, and then everything else is more noise. Another way to think of it here. Pretty cool stuff. You can imagine that there's going to be a whole refinement of research based on this new catalog, and we'll see more of that going forward. One last point of research to mention, we'll have to cover this in more detail in the future, but the USGS has just released archived special reports in digital format. And they've done this for reports published in 1912, 1917, 1938, 1949, and 1950. So these are all now available digitally. We'll go through these in the future, right? To some degree, but there are links to all those available through that link in the USGS website here, right? So there they all are, and like as I said, we'll come back to these and go into detail of these later.
That last one, 1950, is going to be wild.
You want a preview here? Let me see how fast it'll open here. Click through document.
Yeah.
And here it is.
So we've covered that one before in writing and I think mentioning it in video at least. If not, we did videos on it too.
Right. Well, so you got to realize that these are special reports on special topics. These are not just kind of general all the time. Like, there's other information besides this. This one right here from 50 is titled "Abrasion Hardness" by Thomas Jagger and Rudy Finch. Right. So that's more so about that, right? About abradability, hardness, softness, experiments, those kind of things. It's less so about anything that happened on Kilauea or Mauna Loa in 1950, right? To give you an example, just of that one in particular, right? So yeah, that's what we got there, and we can switch to some questions and wrap it up.
Yeah, we really don't have that many questions. If you do have questions, I will make one more scan of the chats. If you want to drop something in there, we do have one from CK who asks, does Kilauea ever have pyroclastic flows?
So there wasn't one event in 1790 that had a pyroclastic base surge. It's a little different, yeah. But that is thought to have killed at least 80 Hawaiian warriors, perhaps up to 800. But it's not exactly the same as a pyroclastic flow, right? So what we have is it ends up being slightly, I mean, in our case, we're having a big explosion. All the ash is going up in the air. Some of the stuff is fine enough; it's going to stay floating. And it's going to basically drift and fly away. Some part of it's going to be too heavy to stay aloft. It's going to go up and then come crashing back down, hit the ground, and flow sideways out to the sides. That's the base surge when it surges out to the sides like that, right? So you can get that without having like a dome collapse from a stratovolcano. You can get that without having a St. Helens kind of deal. It's like a smaller version, right? So
more localized.
But both, I mean, the word pyroclastic is in both, so that's often what trips people up. So not the kind of pyroclastic flows like would come out off of Rainier or St. Helens and go through, or Rainier and go through Seattle. It's rather just like a more localized, as Dane said, surge from that collapsing ash cloud. Yeah. Thanks for the question.
Just don't be around the thing. Good thing is the park will close if there's any chance of that kind of stuff, so there'll be nobody around to catch that, base surge again.
So, it's interesting, along those lines, in 1924, there was an explosion that didn't exactly have that, right? So 24 didn't have any fresh magma unlike 1790, so maybe you have to have extra magma to have it be more explosive, produce more ash. And also, related to that earlier period that ended in 1790, is we think that the volcano didn't have as developed magma chambers in the shallow parts. So the magma may have been coming from deeper and coming up a long way, much faster than it is now. So when you have that rate being higher, interaction with the water, that can cause a bigger explosion, which can cause more ash, and you can have a bigger surge from all that. That's all we had in mind in 2020, when the pond of water was in Halemaumau and the lava came into it, and we really didn't know what to expect, right? And in the end, it didn't explode. It kind of just passively burned that thing away in an hour and a half. But the rate of it coming up was likely slower than 1790. We didn't have any explosions, so I suppose the theory is being refined, right? Right now, try to accommodate for that new information from 20.
Well, we have one question here from Eric. I'm going to modify it slightly. Historically, what's the largest earthquake known due to volcanic activity on Hawaii Island? The on Hawaii Island is the asterisk I'm adding just to make it a little easier, or a lot easier.
Yeah. So the reason I pause is because we have to define due to volcanic activity. And the reason I put that out there is because we've talked about Mauna Loa in particular, and Kilauea has this as well. It happened in 2018, having volcano earthquake cycles, where the volcano can prime the ground for an earthquake, or the earthquake can prime the volcano to erupt, right? So it can go both ways. So are we talking about, like, for example, in 2018, the eruption began on May 3rd, but the May 4th 6.9 earthquake was induced by the drainage of Halemaumau by the magma. So you could say it was caused by the magma and a south flank gravity movement, right? So do we count that one? Do we count a 7.9 in 1868 on Mauna Loa's south flank, right? That closely preceded the eruption from Kahuku, where you can go and visit Kahuku right now, right? That flow went to the ocean, right? Do we count that one, right? So that's easiest answers. The biggest earthquake on Hawaii was a 7.9, and it had volcanic influence right there, right? But if we talk about magma directly breaking rock and what size earthquake can that produce, maybe in the 4s or the 5s, like that, right? Mm-hmm. But if you combine it with the south flank, you can get up into the 7, 8 range, right? And that's the best answer there, right? So really the largest quake. Everything that happens in Hawaii Island is related somewhat, especially on the south side here to the volcanoes, right? So 7.9, I would put it into that due to volcanic activity bucket personally.
Right. And one of the ways we sometimes break it down as well is everything that most other, like there's three general kinds of earthquakes that we look at would be the volcanic related ones in any way, shape, or form. Then you have the deep Pahala earthquakes, and then you have the flex earthquakes from the weight of the island shifting on the. And there's a whole bunch of subcategories within those, but yeah, there's different ways you want to break it down, however you feel like defining that part. The one interesting thing I did just find is that the felt it reports that you can make for earthquakes that happen right now, like say there's an earthquake, you can go into USGS and go to the felt it, make a felt it report, and you just tell USGS what you felt and experienced, stuff like that. You can actually go fill one out for the Great Ka'u quake in 1868, a felt it report. I'm not kidding.
Well,
Just a little tidbit.
We could do some white hack information to them and submit a report there. Hey.
I didn't even think that was possible, but I'm looking at it, and the funny thing is it expires in 2024, so you got to make sure to get in there and get your report in before it expires.
Just watch like a wave of people submitting 1868 reports now, right? Like, we've had a seance, and we have more information to report.
We got the Ouija board out, and we got some felt it reports out of the thing. It's pretty cool. All right. Well, yeah, I think that does it for questions. Appreciate everybody that turned out today. We do these streams normally on Thursdays at 5 p.m. If everything goes off without a hitch, we'll be at 5 p.m. But we will be on. And if something goes down, we get a big earthquake or something along those lines, we will go live and cover it accordingly. But otherwise, we will be back next week, Thursday, 5 p.m. Hawaii Standard Time. And with that, I will pass it to you, Phil.
Thanks, Dan. I really got nothing else to add. Just a reminder about the national park input, right? That we'll at least cover next week. But feel free to go check that out as well. So until then, for Hawaii Tracker, Dan DuPont, I'm Philip Ong. Aloha, everyone.